bit. But I've decided to actually do 2 reactions of anhydride so that you see what I mean. And I have actually put the 2 different carbonyls, one in black and one in red, because there's going to be a difference in what they're going to be doing. So the first reaction, I take my anhydride and I react it with an alcohol. This one happens to be cyclohexanol. So my alcohol is going to attack the carbonyl, one of them, whether it's the one on the left or the right, it makes no difference whatsoever. But I make a tetrahedral intermediate on that side. And now I have my alcohol up here. The alcohol came with a proton, so it's going to be positive for a little bit. I'll get rid of the positive. How do I get rid of the positive? I have pyridine in there. And the pyridine is going to just simply come. Remember, pyridine is aromatic. It has a 6-member ring with the nitrogen, and it can pick up protons because it will not lose aromaticity. And I get my tetrahedral intermediate. It's neutral. Well, it's negatively charged, but good enough for us because we're ready for kicking out the leaving group, and it happens to be this whole second carbonyl group. That's the leaving group, including the oxygen in the middle. So when I kick out the leaving group, we do it by reforming the carbonyl, and we're going to break this bond by giving it the electrons to the oxygen. And that gives me 2 things. On this side right here, we now have an ester, which is what we knew was going to happen. But the second carbonyl, for now it's going to be a carboxylate. And eventually, of course, when we work up the reaction, it will get protonated and it will get you acetic acid. So one of the carbonyls will get us the ester. The other one is going to be converted into a carboxylate, which will eventually be converted to acetic acid. Let's do the reaction again, but we're going to do it with ammonia. In the same fashion that we did, exactly the same thing happens with the ammonia that happened with the alcohol. We attack, we make a tetrahedral intermediate. I'm going to go straight, no, I'm not going to go. I'm going to go ahead and put the positively charged nitrogen. All right, it came with 3 hydrogens, so I'm going to put 2 over here and I'm going to stretch 1 out, because that's why we need the 2 equivalents. The extra equivalent of ammonia is going to come over here and it's going to, it's going to deprotonate our intermediate so that we get rid of the positive sign. Now that we have a neutral tetrahedral intermediate, now we can actually kick out our leaving group right here. So again, reform the carbonyl and give the electrons to the oxygen that's in the middle. So what do we get out of this? Well, here's our leaving group. There we go, our negative oxygen. And here's the amide that we made when we added the ammonia to it. So technically this is the product that we were after, and this would be the byproduct. I need a counter ion for this. Let's assume that I haven't quenched it yet. So I made an ammonium ion when I picked up a proton. So now a negative, every negative deserves a positive, and I'm going to have a counter ion for my carboxylate right there. Esters. Remember that the esters were the 3rd in order of reactivity. So the esters are about as reactive as your carboxylic acid. We can convert them to the carboxylic acid, but we know that this is going to be a slow reaction. And if you know that it's going to be a slow reaction, you're going to heat it up. That will actually get the rate of the reaction a little bit faster. Now let's say that I wanted to interconvert this alcohol group. Remember, we're still doing the nucleophilic acyl substitution. I want to change this OR group for a different OR group. So I'm going to change a second I'm going to add a second alcohol, and I'm going to add quite a bit of it, okay? I need this reaction to give me a lot of my second product, and I will be substituting the OR group for the original OR group. So I made an ester out of an ester. So I'm going from one ester to a different one, and notice the name of the reaction is the transesterification reaction. All right, well, the other thing that was right underneath the ester was the amides right here. So again, we're going to replace the OR for the nitrogen, and the reaction is going to be a good reaction as long as you use ammonia or a primary or secondary amine. Tertiary amines will not do this reaction. I have one more reaction to cover, and I want you to notice very clearly what's happening here. I have my ester, and I add a Grignard. Can you classify this alcohol for me? Assuming this R group is another alkyl group, what kind of alcohol is it? It's a tertiary alcohol. Perfect. And notice that I have two identical groups attached to it. I have two ethyl groups attached to what used to be my carbonyl. Let's see what's happening here. All right, so I have my ester, and we are going to attack with a Grignard. It doesn't need to be this Grignard, it can be any Grignard that we want, but I'm going to use this one. So this carbon is negative, so it attacks the carbonyl and it forms a tetrahedral intermediate. Anytime you get to a tetrahedral intermediate, you have to see if you have good leaving groups. And I do have a good leaving group in this reaction. I have the alkoxy right here. The alkoxy is now a good leaving group because it's not going to be the strongest base in the reaction. The strongest base in the reaction is the Grignard that we're using. So what we're going to do is that we're going to reform the carbonyl, kick out the alkoxide, and this gets us to an intermediate. Let's see what this intermediate is. Reform the carbonyl. We get a ketone out of it. All right. Ketones and aldehydes are more reactive than esters. So as soon as you make your first molecule of this, the leftover Grignard is going to say, hey, look at that ketone, that's more reactive than that one. So this one is going to be attacked by a second equivalent of the Grignard. So a second equivalent of Grignard attacks. I'm sure I'm going to run out of space. Let me see. Yeah, you can still see it. All right, now I have two ethyl groups attached to it. Pardon me, I'm just going to put ET for ethyl. I am seriously running out of space. A second tetrahedral intermediate. Remember, you cannot stop at the ketone or the aldehyde. You have to attack a second time. I don't have any good leaving groups in this tetrahedral intermediate. So whenever we quench the reaction, that's where your oxygen is going to pick up a proton right there. So we always get a tertiary alcohol. I shouldn't say always. I should say that we always get an alcohol with two identical groups when we attack an ester. So we attack esters twice with Grignards. This reaction we're not going to cover for now. We're going to leave it for later. All right. I have a problem.